Is now.
See, I'm working at Plant Innovation and we do a lot of medical product design there. And I'm lucky enough to be on the first project there, building a medical point of care device with MicroPython at its core. So that's really fantastic to have a bit of commercial backing behind all this. And it's really changing all the embedded development. I've been doing development on micros for many years, or in C. You get used to that being the norm. But obviously we like Python, it's a lot quicker to work in, and you get to reuse so much code. There's so much out there already that even if it needs a bit of transfer into MicroPython, it's so quick to do as opposed to starting from scratch in C. But yes, being used to doing Python development, obviously not having the line-by-line debugging is a bit more difficult. So you've got to come up with other alternatives. And there's a lot of just running in terminals, there's a lot of scripts. You can just print all your outputs and check all that, but that's kind of very much like the bad old days of C programming where you had just your UART and trying to see what was going on in a little black box. But with MicroPython, with Jupyter and a MicroPython kernel, you can do stuff more bit by bit and test it out as you go. So there we are, connected. Alright, so here we've got a little ESP, simple NeoPixel, and there we go. You can start testing it out as we go. You can just change the colours, run it again, and just keep reusing the same bit of code over and over. Hi.
Question. Has everyone used Jupyter notebooks before?
No.
Yeah, okay, so I will. This is in the slideshow view of it. I'll go back to the normal view afterwards and it'll probably make a bit more sense then. So, for the people who have used Jupyter at least, the normal version is just running Python on your computer in these cells, and you write your little chunks of code and run them over and over. And with this kernel you can have some cells designated as local, so they'll run in the PC environment still, whereas the regular cells will run on the MicroPython, so you can mix and match between them. And that lets you do some really cool stuff, like use the widgets that are in Jupyter to, say, do stuff live and fiddle with code and test it all out as you go. So that's sort of stuff that you've never been able to do with good old C programming and even embedded development.
Sorry, the Jupyter Notebook's kernel is running on the...
No, so the kernel itself is still running on the computer,
Okay.
but all the commands are being streamed to and from here by the little MPRIPL tool. It's just, yeah, it's still using the virtual serial port behind the scenes, but yeah, all the input and output to that's being redirected into these cells. So yeah, MPRIPL's still in a pull request, but it's basically just a little tool that you can use to connect, command line tool normally, to connect to your device. And what it actually does is it mounts your computer's local folder inside the MicroPython. So from within MicroPython you can see code that's on your computer and access it. So things in the remote directory are actually what's on my PC. So that means you can use that for easing deployment of all your Python code. It's also got these other tools built in, so if you want to flash your firmware, ESP tool can be built in, so you can at least keep a record of what code you're using, and it'll all be stored in your Jupyter files. You can easily rerun that without having to remember commands and copy paste them. And then with the MPRIPL tools, I can just copy everything that's in my local lib folder. So any Python files that are in there can be copied onto the remote device in one line. And it will just update all of them as you go. So you can keep all that very consistent and repeatable and develop on your PC and then keep it all in sync with what's on your device. So another little trick is you can write your code in a cell here and upload this cell to the boot file. So this one is basically taking the color sweeping code we saw before, upload it to the board. BootPy is the magic file that runs at startup. So now we can just, and there we go. So that's freshly deployed code running like power on. Alright, so we're going to, the other thing I've been working a lot with is OpenMV, which is what I was talking about earlier. So this is the little open source imaging platform with a camera. So this here can give you a little demonstration of just how easy OpenMV is to use. This is all the code you need to connect to the board, configure the camera sensor in your formats, compress the image to a JPEG, copy it over the remote to PC, and then, or if it connects, come on.
Should the light still be flashing on the board?
No, I don't think so. Yeah, it worked at PyCon at least. That was the surprising one. But I don't know. This board may have been flashed since back to regular OpenMV code. But long story short, you can take a photo and then in a local cell display it.
That was the one at PyCon too.
Yeah, here's one I prepared earlier. But yeah, it's separate to the IDE that OpenMV make. This is just another way you can, develop with live boards and keep a record of it all. So as I was saying, outside of the slideshow mode, this is what Jupyter Python normally looks like. You've got this sort of a streaming list of cells, and that's all saved in a text file, well, in their own format file. But you can go and just edit your code as you go and rerun cells on the fly. Keep it all stored. And I've found this to be a very productive way to test code and build up quite large projects. So as you're going, you can test little snippets of code, just check that they work, and once they've worked, then you copy them into an actual Python file and upload it as a library, and then just keep building up your new stuff as you go in the cells. And it's allowed us to be quite productive without, say, sort of traditional embedded development tools of the remote debugging.
That's really cool. So we should say, like, Jupyter's like a general purpose tool. It's not necessarily for MicroPython. It's gotten a lot of take up, I guess, in the data science community, where it's used heavily, like, to do data processing, because you can produce charts inline. And so the way it works is it runs a web server on your computer, and you use your browser to connect to it, and this gives you that nice interface with cells to inject code. But yeah, the nice bit is you've got MicroPython kernel, which can redirect the code to a device.
Yeah, it's a really extensible framework, Jupyter, and as I was saying, it's really huge in academia for doing a lot of data processing and then storing, so rather than, say, like a spreadsheet, this will keeps it all visible of what you're calculating, what you're coding, and then you can publish that directly and have a very, very repeatable for other people to rerun your exact same code. And it's just so visual and quick and easy to use. Just add new cells, move them around. It's really quite functional.
Nice. Any other questions? Thanks, Andrew.